So now I want to talk about facades and I want to talk about modularity because I want you to think about how we're actually going to construct these buildings in 3D. I use the term facade, and this is where I want to bring up Disneyland for a second. This is Main Street, USA, and Disneyland. As I mentioned in a previous video, these upper floors are not actually full size. This is not a full size window. It's, I think by this point, maybe 70 or 40% as tall as a window. In fact, as it goes up, I believe they take 70% of the size of each window for each floor to simulate the idea that these buildings are taller than they actually are. And it's also a way of making Cinderella's castle feel really, really tall, or Sleeping Beauty's castle, I don't know which one this is. Really, really tall, even though it's not that tall at all. It's sort of, but it's a relative sizing thing. But the fact of the matter is, even though the street looks like it's a bustling Midwestern sort of Missouri town at the turn of the century, it's not. In fact, if you go behind the scenes, it's all fake and it's all facade. And in fact, facade is a term that was used during the neoclassical era because you'll see a lot of these beautiful buildings that look like ancient Greek or Roman fronts, but from the sides and the back, they're just brick and they look incredibly municipal and incredibly basic. This is because the same thing for 3D modeling, this is what we want to think about, and we don't even need the scaffolding. All we care about is what's on the outside of the building. And in fact, it's very rare in games or movies you ever see inside of the building. We usually have shades or something reflected there. In the case of Spider-Man on the PS4, they actually use a technique called cube maps to simulate rooms inside of buildings. But for the most part, that only renders when you get close to them. So we don't actually want our windows to be transparent. We don't actually need to build buildings inside of it. And again, in a game, even if you're outside of a building and going into it, it's almost always the case that when you go inside the building, they're loading something new or different because it's just not efficient to render it in real time. So we're only concerned with the outside of the building. It's all a lie. Games are just an illusion, but that's okay. The way they do this is with modular modeling. This is a good example. If you want to ever check out the Assassin's Creed team, every time they release a new Assassin's Creed game, it's tradition over at Ubisoft to do a massive, they call it an art dump on ArtStation. Just look them up. They have incredible detailed photos of how they build all their stuff. And when you think about modeling, like this whole street here, that seems really intimidating. But if I asked you to model any of these elements here, you might say, yeah, okay, I can kind of see how I can approach that. I might not have a 100% idea of exactly how to do it, but this seems like a simple enough thing. Well, these are the pieces used to make this whole scene here just fit together in pieces, because who needs to model every one of these windows when the windows repeat over and over again? So we call this modular modeling. It's about thinking about buildings and their construction as something that can be broken up into. This leads to large modular kits, things that can be reused or assets put together. You might have seen kits like this on the asset store, and this is the kind of thing we want to think about being able to build ourselves. It can be applied pretty linearly, so something on the left is closer to the kind of idea of what we're going to be making this week. But it can also be applied modularly, like over on this example on the right, something a little bit more abstract, but it's still repeating forms. They're just not snapping together as precisely. They're laid in a little bit more organically. But make no mistake, these are repeating forms all over this because the artists are trying to save themselves time and effort. So here's a really good example of a piece on ArtStation. I believe I have the artist's name up in a slide here. A really, really incredible looking work. And look at all the detail that's in here, the different rooms, the library, the technology, the stuff like that. But it might shock you to find out that the entire scene that you're looking at here is constructed with just these pieces. That's it. And a lot of the repeating things are just additional books make up a huge part of it. This is the roof section. This is the little archway. There's one pillar. There's one of these walls. All those little computer machines lined up, that's just these three with these wires and then one big element in there. That's it, the whole scene. Everything in it are just those, couple dozen elements put together. This is, Vladimir Lepotek. If you want to check out the slides, of course, they're linked for the weeks, and you can always dive deeper into it. I highly recommend it. Studying other people's work is the best way to learn about this stuff. It's really good for a bunch of reasons. It's resource efficient, so it saves a lot of time. It saves your computer because it can actually instance. It's called instancing, where it just knows it's making a copy of something instead of loading a new thing. So it actually makes the scenes a lot more efficient. So it's one of the reasons it's really crucial for games, especially because it's way more resource efficient, not just time efficient. And if done right, it's not that obvious, because if you look around your own room, things repeat all over the place. All the doors in your apartment building are the same door, so why make multiple? And it can be used for lots of little things. One of my favorite anecdotes is the side tables, the little bedside tables in Skyrim. They were developing and designing the game. They were laying out the labels and they realized the levels, and they realized they didn't have any bedside tables. So they just literally took the bookshelves and they just pushed them into the ground. And so if you do a no clip and you look through, you'll see all the side tables are actually just bookshelves sitting a little bit like halfway through the ground, and it works just fine and hardly anybody notices. So when you're planning on modularity, I always find it's really helpful to do what's called a drawover. So we try to break down a shape into its complex components. So something like the Kame house is a good example where we say, okay, this roof section can repeat, and maybe we can use some of the same textures here. Also, this little corner, if we make the words Kame house a separate stamp we put on top of it, then I can use this and repeat it over here, as well as thinking about the blocks and the things that are going to be foundations. So start to think about what elements can be reused and reformed multiple times. So taking that further, when we want to take that in there, we also want to plan to the kit. I like to think in terms of grids. So there's a really strong grid system that I'll show you inside of Blender that's really helpful for thinking about how to snap these bits together. It's a little bit like Lego pieces where they have universal standards of sizes, where you understand that like 3 flat pieces together make 1 brick. And these many little dots make up a 4x4 or something to that effect. So this is an example of a visual breakup of maybe what could be built into an asset kit for a medieval castle. So I have a little half of a tower that might be good to put together, a boundary wall, a window. And these, if you built all of them, could be assembled together to make an entire set, thinking about them from the front and side view. So try to like break down a building into, from the last image, all its component pieces and figure out what you really need. There's examples of bad modularity, and a lot of these have to do with tiling. So we're going to use tiling textures a little bit in this week, but we can see bad tiling is obviously repeatable. We can see that the tone change where it's a little lighter in the center, and it kind of gives this bend or bowed feature. We want to make it look like it's tiling infinitely without obvious repetition. Also, an inconsistency in size or scale. So this brick texture's size versus this one's really blurred out, and this window's really tiny. We call this texel density. We talked a little bit about some of that last week, but we want to keep these things relatively even to each other, especially in environments. In characters, we can play with a little bit more because some things like the face are more important than the bottom of the shoes. But in buildings, we want to make almost every single area have fairly even texel density. And thinking about not going too high. Again, a mistake I see a lot of people when they start out making is they just put too many verts into a model at first. And in fact, if you look at good environment artwork, it's very simple, and most stuff in an environment is just boxes repeated over and over and over again. You can make a lot with just a couple of cubes. And so simplification is really important to these elements. Yes, there's some really ornate details you can dive into, but ask yourself, how much can I simplify it and still get the idea across? So as I mentioned, the grid is really important for us, and we're going to be using this inside of Blender along with origins. And this idea of thinking about the number of units, we don't want the units of our floor, for instance, being larger than the units of our wall because they don't snap together. Instead, if we make all of these elements even, it lets us piece them in together like a little kit. Again, I like to think about this like Legos or a little snapping together model kit. Or if you've ever used a level builder in something like Skyrim or Halo, you'll see that that's how all of their assets work. So we don't actually need to weld these things together. If they're close enough and they have a tight enough fit, it's fine. If it looks good, it is good, is what we're trying to think about. A nice another thing about this is it makes adjustments easier. If we instance all of these walls and I make a change to this wall, it will apply to all the other walls. So when we're working though with this snapping, maybe one of the most important things to think about is what's called the object origin. Now, you might have noticed on your models, there's a little dot somewhere on it. And when you start, the dot is almost always at the center of the object. This is the origin, meaning when I rotate it, scale it, or move it, it's happening from that point. Well, it's really important for snapping to think about where should these elements snap together. So you see all these walls, the origins are in the lower corner because I want to be able to snap this to this and get them to line up with each other. Versus this corner and this corner here have their origins in the same spot. So if I gave them the same location in 3D space, they would snap right next to each other. Same with all of these. I'm always thinking about where these things should snap in together. In the next video, I'll show you actually how we can use grids and snapping in Blender to help everything sort of piece together into a nice, satisfying modular kit. So I'll see you in the next one.